So when we ended yesterday, we were talking about stretching and compression of functions. And our general pattern here was that if we had y equals f of x, when you multiply it by a constant greater than 1, it stretches by a factor of c. So that's right here. Y equals c times f of x is f of x stretched here by a factor of c. And if you multiply by 1 over c on the outside, where c is greater than 1, so it's like 1/2 or 1/3, then 1 over c times f of x is shrunk vertically by a factor of 1 over c. So if 1 over c is 1/2, c is 2, then it's half as high. And we saw that with our sine and cosine graphs here. So the blue graph is cosine x, and then the green graph shrunk by a factor to half the height is 1/2 cosine x, and then the red graph is 2 cosine x. It's stretched vertically by a factor of 2. And then remember, multiplications on the inside were horizontal stretching and compression. So f of c times x was the graph of y equal f of x shrunk by a factor of c. So here when we had cosine 2x, that's the red graph. So that's going to be cosine x, which is the blue, and it's half as wide. So the cycle here is length pi instead of length 2 pi. And then cosine 1/2 x is the green. When you've got 1 over c times x on the inside, then it's stretched by a factor of c. So the 1/2 x is going to stretch it to be twice as wide. So you can see half of a cycle occurs in 0 to 2 pi, and then the other half of the cycle would be from 2 pi to 4 pi. So we got one entire cycle of cosine 1/2 x there. If you got a negative outside, that's going to be a reflection over the x-axis. If you got a negative inside, that's reflection over the y-axis. So let's put some of this stuff to work here. So I've got a worksheet here I want you to take a look at. So here's our graph of y equals f of x. Notice that the y-intercept is at 2. And then what you want to do here is watch where the dips occur and what happens to your y-intercept. So we want to match these 6 graphs with the 6 equations here. So why don't you pause the video for a second and see if you can match these up using your vertical horizontal stretching and shifting. Okay, so part A here, we've got f plug in x plus 3, so that's going to be a horizontal shift, and that's going to be to the left 3 units. So this will be left 3. So we want to look for this graph moved 3 units to the left. So this point 0, 1 is actually going to be negative 3, 1. It's going to be right there. But it's going to keep the same general shape here. So it's not going to be stretched vertically or compressed. So to me, I'm looking at this right here, and I see that right here. Now it's kind of hard because they've graphed a little bit more, the graph that we didn't see before, and then they took this piece here and they chopped it off. So I think f of x plus 3, a left shift, is graph number 2. So I think this goes with A. B, x minus 3 on the inside, so that's going to be a right shift of 3. So now we're looking for this graph, and it's shifted to the right 3 units. So I'm looking for this piece shifted to the right. So this then is going to come over here. So I'm looking here, looks like this one right here. And if we shift, another thing you can pay attention to is the x-intercept. So here our x-intercept, this is negative 2 right there. That's negative 2. So our x-intercept was about negative 1/2. So if you shift it to the left 3, now we can see here our x-intercept is about negative 3.5. And then if we shift it to the right 3 units, it's going to be up here at about 2.5, and you can see that this intercept is about 2.5. So it looks like this one is B. your right shift. And then let's see here, 2f of x. I'm going to skip this one for a second. 2f of x. So that's going to be vertical stretch times 2. So this is vertical times 2. So that means that this y-intercept that's at 1 is going to be up at 2. And then this next peak here that was up at height 4 is going to be up at height 8. Okay, so we're looking for a y-intercept of 2 with what's left. So that's got a y-intercept of 2. This one does not. This does not. This does not. It's got to be this one. Okay, so, and we can see here the 2, we've got this bottoming out just before the 2, and then this maximum is at about 3. And you can see this bottoms out just before x equal 2, and then this is x equal 4. Our maximum is about x equal 3. So I think that this one is D. So now we've got these guys. And then 2f of x minus 1. So this is going to be take the graph for D and shift it down 1 unit. So here's our graph for D. Instead of hitting at 2, it's going to hit at 1 right here. But we're looking for something that's got that same general shape. So here, this looks like this is compressed horizontally. It looks like it's narrower, so that guy is out. This one looks like it's shifted down 1. Take this. Let's see, this bottom, this valley here, minimum was at about 5. And here it's at 4. And your y-intercept of 2 now is down at 1. So this looks like this is E. And then f of 2x plus 2 and f of 2x. So let's do the f of 2x. So that is going to be horizontal compress by a factor of 2. So it's going to be horizontal compress. It's going to be 1/2 as wide. So this side's going to get pushed in like this, and this side's going to get pushed in like that. It's going to be narrower than it was. So we are looking, I got 2 choices left, this one here and this one here. Now f of 2x, when x is equal to 0, 2 times 0 is still 0. So this is going to have the same y-intercept as this one at 1. Now here our y-intercept looks like it's up at 3. Here it looks like our y-intercept is at 1. Okay, so that's telling me this one's got to be our f of 2x. So that's going to be C. And then f of 2x plus 2, we take graph C up 2. So C shifted up 2. So we take this one, shift it up 2. So your y-intercept of 1 should come up here to 3. Yep, that's where it is. This peak here gets shifted up here. Yep, that's looking like it's doing the right thing. This peak down here is getting shifted up to here. So it looks like it's about the same width here. So this one should be F. So we got C, got F, we've got everything there. So hopefully that makes sense.